Okay, so this is to address the issue of transformations. And I'll do it in the context of multiple regression. So the first thing we're going to do is a multiple regression. So it's just the one that we've been doing in the tutes. You can see here it's all set up and ready to go. I'll just spread that out so we can see what's going on. The reason I'm doing this first is you would only consider a transformation because a distribution is causing problems for an analysis, so an assumption isn't met. In the context of multiple regression, it's not actually a requirement that each of the variables be normally distributed. What is a requirement is that your residuals are normally distributed, along with linearity and homoscedasticity. So I've also requested the plots. Okay, so just to be clear, I've got the Z predict, so that's standardized predicted scores on the x-axis, and S-resid, studentized residuals on Y, and I've got my histograms and normal probability plots selected for getting a residual plot, and you can see those down there. Okay, so having done that, we now just continue to that, and I've already selected all my statistics there previously, so we just say OK to that. And it'll have a bit of a think about it, and then it runs the multiple regression. So I'm going straight down to my charts. Put you down here. Okay, so I like using the navigation pane, so I want to go straight down there. Okay, charts. Okay, and here we can see histogram of the residuals, normal plot, and when it's ready, there's the residual plot. Okay, all three of those are useful. So what I see is that my residuals are fairly normal. All good here. Oh, hang on, grab a pen, right on the screen. So this area here is fine, and this area here is fine, but these scores here should probably be down in that area there. So it's not quite normal. Okay, I reckon it's good enough, but just for the exercise, I'm going to explore whether perhaps one or more of the variables is a bit odd, and that's causing my residuals to be a bit odd. So in order to explore that, I'm going to go analyze. Still got pen happening. I'm going to go analyze. Now I want descriptive statistics, so I'm going to go explore. Okay. And I've got these set up because I've already had a look at them. So you can see there, notice that even though it says dependent list here, I haven't just got the dependent variable in there. I have all of my continuous measures in there. Basically, this top box here is where you put continuous measures, and the bottom box is where you put any categorical variables. Okay, so if I wanted to look at descriptive statistics separately for my categories, I would put gender down in there, and then I could see descriptives for genders separately. But I don't want to do that. I just want to have a look at the overall distribution. You might also notice that I've put subject number down there to label cases. When you're trying to identify individuals that are unusual, it's good to do it by their case number, in this case subject number. Okay, so we're ready to go on that. You'll also notice that I have selected histograms, gotten rid of stem and leaf, and gotten rid of box plots because you want histograms. Okay, so we say OK to that. Now that's just a procedure you learned how to do in first year. So, you know, I know that's a long time ago, but hopefully it rings some bells. Hopefully it's not the last time you did it. So we get this big table of numbers. So we've got means and everything else that we need for each of the different variables. So I've got the IV, the DV, and all the IVs in there. First thing I'd have a look at is the shape of the DV. If you get skew in your residuals, that's usually why you get it. But on this occasion, that's pretty normal. So that's not causing my problem with my residuals, so it's unlikely to be. Ooh, reading is a little bit negatively skewed, not bad. What have we got there? Spelling scores, also a little bit skewed. And if I scroll down a bit further, cognitive skills, badly skewed, and engagement's not too bad. So there's cognitive skills, badly skewed. Engagement, I've just got an outlier. Okay, so I've got an outlier there. But if I take that person out, the rest of this is reasonably normally distributed. Not too bad. Okay, so I doubt the engagement's causing me a problem. The outlier does, and we've looked at that. That's person 172 that we've looked at before. Okay, so I've decided that the worst distribution there is this one, cognitive skills. So I'm going to try a transformation on that. Okay, as I said, that distribution of residuals wasn't that bad, but just as an exercise, I will show you how to do a transformation on this. So the problem here is negative skew. Okay, so my skew is that way. Okay, so negative skew. Problem is transformations are, if I do a square root or a log transformation, what it's going to do is it's going to grab the numbers up here and drag them that way. And I don't want to do that. What I want to do is grab this tail out here and pull it back that way. So at this point, a square root or a leg transformation is going to do the opposite thing to what I want. So that's no good. So the first thing I have to do is flip this distribution. Technical term, I'm going to do a reflect first. Okay, which is to say I'm going to turn it from negative skew to positive skew. Show you how to do that. Okay, so to achieve that, what we do, we go, let's see, I go back to the data, transform, I'm going to compute a new variable. Oh, but the first thing I need before I do that, I need something from my output. So if I go back here, what I need to know what the highest score is. I need to know where this distribution ends. Okay, so what's my highest score there? Let's see, I'm going to go back up to those descriptive statistics that I produced. Look for orthographic and phonological skills, and maximum score is right here. Maximum score is 38. Okay. So that's important. I need to know that number. Because what I'm going to do is I'm going to subtract all my raw scores from one higher than the maximum number. So first thing I'm going to do here is going to name the variable. So I'm going to say cog, got the caps lock on, so let's change that. Cog Actually, I'm going to do this in 2 steps so that you can see it. So first, I will just do a reflection. Okay. So what I want to do is I want to say a score of 39 minus cognitive skills. Okay. Now I went for 39 because the maximum score was 38. If I had said 38 minus cognitive skills, then my highest score, which is a 38, would have been 38 minus 38 and would have given me a 0. And you don't want zeros when you're doing a transformation. Okay, it's a mathematical thing. A square root or a log transformation. Square root of 0 is 0. Square root of 1 is 1. The 0 and 1 won't change in relation to each other, but every score higher than 1 will change. So you're not having the same effect on all scores in the distribution if you've got a 0. Other scores will not change. With log, it's even more complicated. So just a simple thing is never have a score of 0 in the distribution if you're doing a transformation. Add something, subtract something, do whatever you need to do so you don't have a 0. Okay, so that is going to produce a reflected distribution. I'll show you how. So I've just done that, 39 minus cognitive skills. I click OK to that. So now in my data set, I go to my data, there we go, and slide out to the end, I have a new variable called cog_reflect. So notice that person there had a 35 and now they have a 4 because 39 minus 35 is a 4. That person's 34, so they're now 5, etc. Okay, and I'll show you what that did. So I'm going to go back to Explore again. I'm going to get rid of all these. And I'm going to put cog_reflect in there. Just for fun, I'll put the original one in as well. So now my plots should still be histograms. They are. Everything else is good. I'm going to say OK to that. So this is just getting descriptive statistics for those 2 different distributions. Okay, and I'll slide up here to the numbers. Notice the skew statistics. Okay, and what you've got is a skew of 1.02 there, and a skew of 1.002. Notice that the skew in the original, which was orthographic and phonological, was negative, but now in my cog_reflect, let me get rid of those circles. Now on cog_reflect, it has become positive, and you'll see what I'm talking about in histograms. There's my new one. There's my old one. See, just flipped horizontally. That's all I've done. I've just flipped it over. Okay. So the person who did have a score of 38, who was here, 39 minus 38, they now have a score of 1 on the new one. So they are now a score of 1. So that person has moved down to there. And the person who had the lowest score, whatever it is, has now moved from the bottom to the top. Okay, so I've just reflected it. I've flipped it. Okay, which means that if high scores meant, if in the original data set, high scores up here meant you were good at it, having reflected it, high scores now mean you're bad at it. Okay? So it means the opposite thing. Hopefully that's nice and clear. So now I had to do that because my square root or log transformation is going to grab this part of the distribution and drag it down, and that's now what I wanted to do. I wanted to grab the tail and pull it in. Okay, so having reflected it, I can now do the square root or log transformation. So let's now do a square root transformation. Again, I go back to compute variable. I'm going to reset that and going to call it cog tran, and I'll go sqrt, which is short for square root. Okay, so now I have a look over here in my functions. So notice this bit here. That didn't work very well. Oh, it's not enjoying this. My computer's keeping up with me. Function group. Okay. So within function group, I select all because I can never remember where it hides square root. I would have thought it would be under arithmetic, but it's not. Okay, so we'll just make do with this. So I'm going to scroll down to the S's. It's all nice and alphabetical. S, there we go. SQRT. Notice that in this section in here, it's telling me what that function will do. Okay. So it's going to give me the square root of whatever number I put in there, and that's what I want. So I grab that, put it up there. So it says SQRT, and then in brackets it's got a question mark. Square root of what? Good question. I want to take the square root of these new values that I calculated in cog reflect. So I put that there. Okay, and that's going to get me done. So I say OK to that. And now, out in the data set, notice I have yet another new variable. This is cogtran squirt. Okay, and what it's done is this number is the square root of that number. So square root of 4 is 2. Do I have another easy one? No, I don't. But anyway, that's now working. Okay. Okay. So now I'm interested in whether that has made that variable normal. So again, I'll go back to Explore, and this time I'll put in that new one. Okay. And yeah, let's leave the old ones there so we can compare them. Okay, so OK to that. Rather hoping it's done it. What do we got there? Yes, it has. Okay. So if I scroll down here, there's my reflected one. There's my original one. And here's my new one. A little less skewed. Not fantastic. So let's go back up. Here's the output for that. Notice my skewness statistic. 0.323. Standard error of 0.18. So 0.18 times 2 would be 0.36, so I'm a little bit under 2 standard errors. Standardized skew of just under 2. So I could live with it. You know, it's not that badly skewed. If I look at the histogram, you know, that's getting more normal. If I wanted to get more aggressive in my transformation, I can come back here and instead of square root, okay, so I can reset that, and this time I will go again, cog tran. This time I'm going to do a log transform. Same thing, I ask it to list all my functions, and this time I'm going down to the L's looking for log. Now you'll notice LG10, that's log 10. There are others listed there as LN gamma. LN is normal logarithmics. It's a complicated maths thing, don't worry about it. Use the log 10. That's usually your best bet. So I get LG10, put it up there. Again, it's saying LG10 of what? Well, my reflected cognitive skills score. Okay. So I put that there. Say OK. Again, it's giving me a new score out here. And now I will go back and have a look at the descriptives for that one. Let's throw that in. Run OK again. So let's now run those. And if I go down and have a look at my skew statistics, okay, oh, that's actually starting to produce negative skew. I don't want that. Did you see what I was looking at? I was looking at, so the square root transform gave me those skew statistics. My log transform gave me those skew statistics. So I've actually gone from positive to negative and increased it a bit. So log may have been a poor choice. Let's scroll down and have a look at the histogram, see what's going on in that. So there's my square root one, and then there's my log. Well, it looks normal. The problem is the gaps over there on the left-hand side. So I have less data out here because of these gaps. Okay, so it's calling it negative skew because it's got more over here and fewer over here. So that's, yeah, technically it's come up with negative skew, even though the bubbles in the middle, it looks kind of normal to me. But anyway, so that's how you do square root and log transform, and you just have a look and go, okay, which one is most effective? So let's say that this one is our best, okay, our square root one, and what we want to do now is redo the analysis. So we go down to regression, linear, and where we had cog skills, take it out, put in the square root transform, and run the analysis. Slowly but surely. Okay, now it has jumped straight down to the charts, which is no bad thing. Now I did the transform because my assumption of normality of residuals was a little bit iffy. Still a little bit iffy there. Okay, but it's so close, it's really not a problem. Just for fun, let's see if the log gets my assumption any better. Man, so took square root out, put the log in, rerun the analysis. So I think let's run it. Okay, so I'm going to scroll down to my charts. Let's see what we got. Okay. So that's, that's pretty normal. Okay, and that plot's got an better. Residual plot's just a big box of dots, no patterns, no nothing. So that's all good. Okay, so I'm pretty confident this last one definitely meets my assumption. So now let's look at what results I get in that. It says 55% of the variance is explained, and reading, spelling, and cognitive skills make a contribution. Engagement is close but not quite. That should be familiar to you, because if I go back up to my very first multiple regression with untransformed data, I find that I I started with 53.9% of the variance explained, so R squared of 0.539. Okay, I'm looking here. Okay, I've got 53.9% there, and if I scroll down to my coefficients, I had them in a slightly different order, but that's okay. So the first three are significantly contributing. Engagement is not. Okay, so that's what I had with the untransformed data. Now let's go back to my two lots of transformed. So this one here, the second last one I did, you'll see there it says one of my IVs was, no, that didn't work. Okay, yeah, that cognitive skills square root. Okay, so that's using the square root transformation. And if I just go down to my model summary with the square root transformed, I changed from 0.539 as my R squared to an R squared of 0.546. So I changed R squared by 0.007. I'm going to say that's no big deal. And if I look at my coefficients table, again, I've got reading and spelling are significant, so is cognitive skills, but engagement is not significant, which is exactly the same pattern that I saw initially. And if I go down to the log transformed results, which is here, you see there, cogtran log is the IV. So this is using that one. If I scroll down a bit to my model summary, come on, there it, just missed it. There it is, 0.550. So instead of 0.539, I've now got 0.550, a difference of 0.011. Again, that's nothing. Okay. If I went out and got another sample of participants, could easily change that by that little bit. That's just random sampling error. That's nothing to worry about. And if I look at my coefficients, again, same story. Spelling and reading contribute. Cognitive skills also does, engagement doesn't. My beta for cognitive skills has gone up a little bit from where it started. I think it started at about 0.18, it's gone up to 0.20. Again, nothing to worry about. So all those transformations made no difference to the results of the regression, which is why normality of the variables is not an assumption of multiple regression. Normality of residuals is. So my slight problem with my residuals meant that I thought, well, I'll have a look and see whether one of the underlying distributions is causing a problem. I found the worst one, I fixed it, and it didn't change the analysis. It did get me to where my assumptions were fully met. So again, back at those charts. So that says that's normal, okay? Those residuals are normal. So I can trust these results. I know they are valid because my assumptions are met. But they are indistinguishable in any meaningful way from the original results. So the original results must have also been valid because they're basically the same results. Therefore, the skew in that cognitive distribution was not causing me to get invalid results, and therefore that skew doesn't matter. So I'd go back and report the original data. So that's how you do a transformation and why you do a transformation in multiple regression. If it changed the results, if my results after the transformation were different, then I would use the transformed data. and report that, and I would explain why. But in this case, it didn't make any difference, so I would simply say, due to concern over normality of residuals, a transformation of cognitive skills, which was badly skewed, was performed. Analysis was rerun. Results did not meaningfully change. Therefore, the untransformed data is reported. Something along those lines. Okay, I hope all of that is helpful.